operations on prepositions using truth tables. Good. So the question is, what then? Okay, hello. Hello. Hello, class. Hello.
Yeah.
Okay. Yeah, so we want to continue from where we left off yesterday. Okay, we're looking at prepositional logic, but I think we're having too many challenges. That's why we postponed the class. So instead of just starting off from where we left off, which was at Disjunction, okay, I want us to begin the class whilst your colleagues join. So I'm going to play the video and listen attentively. I'm here. Okay, so if you have any questions, you ask. Sure. Logic, I want us to cover these two topics in this third tutorial. Good. So for topic 5, we expect that by the end of this topic, we should be able to explain the concept of prepositions and apply operations on prepositions using truth tables. Good. So the question is, what then is a preposition? What is a preposition? Just a minute. A preposition is a statement which can be true or false, but it cannot be both at the same time. Okay, so for example, if I ask you if it's Messi, or when I make the statement, Messi is a footballer. Okay, Messi is a footballer can be true or false. Okay, another statement will be the earth is round. Okay, the earth is round could also be true or false. Okay, Accra is the capital of Ghana. It can be true or false. Okay, but there are certain statements which are not prepositions. Statements like questions. Do you speak English? Okay, so if somebody asks you, do you speak English? You cannot say that it is true or false. Okay, the same way, if somebody gives a statement, a command, come here, okay? So if I say that come here, you cannot say it's true or false. Come here is a command. Questions are also not prepositions, okay? So you take note of that. Yeah, now let's take some other examples. So we're saying that in prepositional logic, a preposition is represented using a lower case letter such as P, Q, R, S. Okay. If we have just one statement, we'll use the first letter, which is P. If there are two statements, we use P and Q. If there are three, we have P, Q, R, 4, P, Q, R, S. Okay. But what we should take note of are the letters capital T and capital F, okay? Capital T and capital F in prepositional logic, okay, are not statements, okay? They are not statements. We'll come to that in the next slide. I'll explain better on that. Okay, so we have an example here. We say, for example, we can use the notation P is the earth is round. Okay, so P, then you see you have the column representing it's a statement. Okay, so the statement P is the earth is round. Okay, to define P as a preposition, the earth is round. Okay, let's continue. Now, one or more statements can be put together, okay, to form compound statements. And to do that, there are a number of rules which are used, okay, which are used to combine statements. So, for example, if I have the statement Messi is a footballer as the statement P, and Q is footballers score over 20 goals, okay, then I can combine the two statements with a conjunction like and say that Messi is a footballer and scores more than 20 goals, okay? Once I do that, I've formed a compound what? Statement, okay? So there are a number of principles that are used in combining statement. But before we proceed, let's take a little exercise. And in prepositional logic, we have what we call as truth tables, okay? Truth tables are tables that, present the possible truth values, okay, of any given statement. So, for example, if I have the statement P, if I have a statement P, okay, P could have the values true or false. It can be true or it can be what? False. So in the creation of a truth table, you construct a table like that. Then you have the statement P with the possible values what? True and what? And false. Okay. Now, if we have two statements, okay, if there are two statements that is P and Q, okay, then you realize that because P itself has the statement true and false, and Q also has the statement true and false, okay, then the possible, okay, values on the truth table for the two statements, okay, are going to be the combination of these truth outcomes, okay? What I mean by the combination is because we have the first event and then the second event based on the multiplication rule. If the first event has true and false, okay, then the second event, given that the first is true, the second could also be true or false, okay? And given that the first statement was false, the second could also be true or what? False. So which means that at the end of the day, we'll have the truth table for two statements looking like this, P, Q, okay, and because we have two statements here, we'll write two T's, so truth, okay, then for the first one is true, okay, where T, truth, and then truth and false. So truth, false, okay, then we come here also, that will be false, okay, false, true, okay, and then false, false. Very well. So this is for two statements, okay? This is for two statements. Now, the general principle guiding the number of combination, okay, of given statement is the formula 2 raised to the power n, where n is the number of statements, okay? So if we have 3 statements, say P, Q, and R, then your n is 3. So it means the number of combination we expect will be 2 raised to the power what? 3, which will be equal to what? 8, okay? So if it's equal to 8, okay, then what we do is we construct the table. Of course, we could have used the tree diagram, but that would be lengthy, okay? Now, I'll show you a shortcut very soon, okay? So, okay, let's do this. Before we construct for 2 raised to the power 3, let's look at this. In the case of 2 statements, we had 2 raised to the power 2, okay, which was what? 4, okay? So because we're going to have 4 combinations, what you first do is you divide this 4 into 2, okay, and you get 2. So you write 2 truths, 2 false, okay? Then you divide the 2 into 2, you get 1. So you write 1 truth, 1 false, 1 truth, 1 false. The same way as a shortcut, we'll divide this into 2, okay? It means we are going to get 4, right? So we'll write 4 truths and then 4 false. So let's do that. We have true, 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 true. Okay, that's for the 4 true. Then we have false, 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 and finally we have false. Okay, good. Yeah, but let's not forget the headers. That's P, Q, and what? And R. Okay, so we are dealing with 3 statements. So P, Q, and R. Okay, then we divide again by 2, like I showed you from there. That will give us 2. So we're going to write 2 truths for the Q. 2 truths, 2 false, 2 truths, and then 2 false. Okay. Then once you divide by 2 again, this is 2, right? So once you divide by 2, we are going to have 1, okay? So then you write true, false, true, okay, true, false. Then we have, so it follows like that, true, false. So here you have just 1, 1, okay? So false here. Then we have true, and then we have what? And then we have false, okay? So this gives us the combination for 3 statements. I hope the development of the truth tables are clear enough. Very well. Okay. So if there are any questions, you can ask before we move on. But if not, then I'm moving on to the next slide. Okay. So let's continue then. Yeah. So like I said earlier, we could combine 2, we can combine 2 or more statements using logical operators. Okay, and then two of such logical operators are the conjunction and disjunction. Okay, conjunction and disjunction. Good. Now, what do we mean by conjunction? Conjunction is and. Okay, the conjunction of two statements P and Q is and. Okay, and it's written like that. It's like the carrot. Okay, good. Now, when we talk about and implies that both statements have to be true for the resulting combined statement to also be what? True. If one statement is false, then the conjunction of the two statements will be false. Okay, so the truth table for conjunction is given in this table, which I want you to take note of. So take note of this table. If possible, put it down because we'll use it for analysis subsequently. Okay. So having taken note of the table, you realize that the only scenario where we'll get a truth value is where we have truth and truth. Okay. So truth and truth will result in what? Truth. Right? Otherwise, we have what? False. Okay. Truth and truth will result in true. Otherwise, we have a false value. Very well. Then we also have the disjunction. The disjunction, also known as or. Okay, is that is P or Q. Okay, P or Q. P or Q. So that is a disjunction. And disjunction means that one has to be true for the whole statement to be true. At least one has to be true. So if we say that Messi is a footballer, or Messi scores goals or scores 20 goals. Okay, once Messi is a footballer, it's enough. Even if he doesn't score 20 goals, because we are using the word or, and Messi is a footballer indeed, then the statement, the compound statement remains what? True. Okay, the compound statement will remain true. And for the sake of the size, the bundle one, the bundle width, and the size of too huge at the end of the day. Continue. Okay. Yeah, let's continue. So for all, like you can see from the table here, okay, the only instance where we get a false for the resulting compound statement is when both statements are false. Okay, and I'm sure you've taken notes of the table as well, because we'll be using it for analysis later. Okay, let's proceed. Now, we have statements here which we want to conjunct and disjunct. We have the first statement, P, which is the earth is round. And then the statement Q, a decade is 100 years. Okay, clearly we know that P some way, somehow is true. We can say, for now, we can say the earth is round, okay? And then a decade is 100 years. We know that statement is what? Is false, right? Decade is not 100 years, but earth is round. At least we can consider that for the purposes of this class, okay? Now, then the conjunction of P and Q, the statement P and Q, which is the earth is round, and this is the conjunction, okay? This is a conjunction. So the earth is round, and a decade is 100 years. Will be what? Will be false, okay? Will result in a false statement. Why? Because we said once you have truth, okay, and a false, okay, it will result in what? In false. Okay, so a truth and a false will result in a false. The only condition under which conjunction will result in truth is when both statements are true. Okay. On the other hand, P and P or Q, that's a disjunction of P or Q, will be written as the earth is round or a decade is 100 years. We know this is false, but the very fact that this statement is true, okay, makes it true or false. True or false, which is what? Which is what? True, okay? So the truth, disjunction, false will give us what? Truth, okay? Good. And on that note, you would notice that in prepositional logic, like I said earlier, the values T, capital T, and F, capital F, are reserved for what? Are letters reserved for the truth value. So it's either true or false. So assuming I write a statement like P or true, okay, P or true, okay, when I write a statement like P or true, this is not a statement. There is only one statement here, okay? So in the construction of the truth table, it will look like this. You have your P is a statement, so it has two possible values, which is true or false. But the value T is a value. So it means you just repeat the same value in the table, okay, for onward analysis. It's not a statement to have two possible values. It's a value, so truth is truth. If it is false, it's also false. Okay, it does not change. So take note of that. Very well. If there are any questions, you can raise your hand. If not, I'm continuing with the presentation. But you can let me know if you have questions along the line. Good. Now, another statement we need to take note is the negation of a statement. Negation is just, okay, it's usually written as P bar like this, okay? So we write, there are actually three ways of representing it. So we have P bar like this, okay, which we usually refer to as complement. When we went to set, you saw this over there, okay? In prepositional logic, we have it this way, or we can have it this way, okay? Or we can have the negation of P this way. Okay, so either way, we are still saying the same thing, which is the negation of the statement P. Okay, and it simply means not P. Okay, so not P, if P is true, then not P will be false, and if P is false, not P will be true. So if P is the earth is round, then the negation will be what? The earth is not round, okay? Which will be a false statement, given that P is also true. Yeah. So I have a little combination here. This is a loop, okay, where you have the representation is a circuit, a digital circuit, where you have this, okay, logical prepositions represented, okay, using gates. So this is the conjunction, or what we call as the AND gates. The conjunction we'll be looking at, okay, is called an AND gate. An AND gate, okay, an AND gate in computer architecture or digital electronics, okay, where we have the OR gates, which is the disjunction. This is an OR gate, okay. So basically, let's do some little fun. I think something little. Let's go out of mathematics class a bit and come back. Okay, so let's see what this basic circuit does for us. Let me clear the screen. So looking at this basic circuit, if I decide to on, okay, I have my AND. You see, look at it carefully. Let's begin with the OR gates. We have all the 3 bits. Once the disjunction is true, this is the AND gate. Okay, this is the A and D, that's the AND gate. Okay, and per the description, what we just demonstrated, okay, we said that for an OR gate, you only needed one circuit to be on or to be true. Once the disjunction is true, okay, you find out that 3 bits have been displayed on the LED screen. Okay, 1, 2, 3. I connected all 3 to the same line. Okay, it's not properly designed for this thing, just for demonstration. So if you have both being true and true, it remains true. But if both are false, then it will go off. Okay, whereas when you come to AND gate or the conjunction, if one statement is what? If one statement is true and the other is false, it means off. But if both are true, then the bit output, okay, is on. So the bit is displayed on the LED screen, like you can see. The same way when you come to the other AND gate, you put one on, nothing will display until you have both on. Okay, and then once we put on this, we can see that our statement has generated what? The digital letter 8, okay, for us. That is how our computers display our phones and computers, calculators and all that display our figures for us. So this whole concept we are learning is very relevant to us as scientists, like we said from the beginning. Now let's go back to class, to mathematics class. That was a bit of digital electronics For those of you who have taken the course already, I'm sure you get a better picture. Okay. Now, we are told to write the truth value of each of the prepositions below, where we've been told that P, the statement P is true, the statement Q. Yeah, I can see. Oh, okay, the simulator is simulating. Okay, let's continue. No, I think this particular one, I used logism, okay? Logism is, sorry, P is false, Q is true, and then R is true, okay? It's written here. And we've been told that A is P or Q. What will be the result for P or Q? Will it be true or false?
It will be true.
Yes, because we are. Yeah, so class, try question 2, A to D for me. Try question 2, A to D for me. And give me your answers. Mass 201 class, I'm expecting your answers. So try question 2, A to D for me. Okay? Yeah, so what did we get for 2A? Question 2A, what are we getting? Kobe. Kobe, question 2A. Truth. I think I heard truth from Kobe. Yeah, so let's check whether that is true. The statement says P is false, Q is true, R is true. So if you have P or Q, that will be false, false, or what? Or truth, okay? And from the table, this is going to be what? Truth, okay? Yeah, so Kobe is right. Yeah, let's have the next person, Kenneth. Question B.
Is it true?
Okay, so that too Kenneth says is true. Let's check. So that's truth or false. That will also be what? Truth. C. Manuela. Okay, I think I heard a false from her, though it's not clear. Manuela says it's false. Let's verify. So in verifying, you check the bracket first. That will be, this is not of Q, so that will be false. Okay, false and what? False, not of R is also false. So that should give us false. Okay, false and false will be false. Then not of P is truth. So we have truth or a false. So it's going to be truth instead. Okay, the answer is what? Truth. Okay, that is how you do the analysis. So it's not false. Yeah, D. D, Priva. Priva. Okay, can somebody else give us the answer? Priva, are you in class? Okay, Salif. Salif, we didn't hear you. Okay. It might be network issue. So let's continue. So just a minute. Okay. Yeah, so my screen is gone off. Let me just so today we are is P or Q? Yeah, then we were on the last question, so let's try that. P or not R will be false or false. That will be false, okay? Then Q or R will be true or truth, okay? So that should be true. Then we have R or P will be true or false. That will also be what? That will be truth, okay? Then we have or here, we have and here, but you always give priority to and, okay? That's conjunction. So and is always given priority. So false and truth will be false. And then you have false or truth will end up as what? As truth, okay? So the final value will be truth. Then okay. Salif already gave us the answer. We didn't see it. Okay. So we have the next one. It says, given the statement, write the following prepositions as using P and Q as logical connectivities. Okay, so temperature is more than 40 degrees, but it is raining. How will you represent these two statements using logical connectivities? The temperature is more than 40 degrees, but it is raining. How will you represent it?
So P and Q.
Yeah, P and Q. Good. So the temperature is more than 40 degrees and it is raining. The reason why there is a but there is we don't expect it to be raining on that day. That's why we're using but, okay? But it is simply temperature is more than 40 degrees and it is raining. Okay, B. B, how would you put it?
So P not and Q.
So not P and Q. Okay, let's see. So temperature is less than 40 degrees and it is raining. Yeah, you're correct. Then the final one, can we have Ajwa Manuel to give us the answer? Manuel.
Yes, sir.
Yes, can we get your answer for the last one? C. Okay.